And yes, and yes, and then we just find the bar was and then but I mean well no, because tomorrow would be beneficial, at least this one is shorter one, I don't know. Well, the same with you. Well, no, it's work related stuff, so it's not too big. But yeah, so
one morning I was working with them.
that would be great.
We done a show. You need AD too. Speak of the devil.
The doctor.
We have spoken.
We met. We met. There's a third seat if you want.
I'm okay. But you actually really can, I think, I mean, this is.
I don't think so. I mean, just the for the first 10 minutes. Right?
Yeah.
Okay.
Then you're certified, and then I think it's in that's probably on a paper religion, maybe. But after that,
You can play it by ear. I mean, we'll probably click through both the requirements and testing, but you can pick up on your own.
How do I spell your surname more? Zamti.
ZANATY.
H-U-R. Video codec.
Right. All right, sorry we're starting a few minutes late, but had some important people that we were waiting for. Welcome everyone to Netvc. A few things before we get started. We have quite a bit of change in personnel, so we'd like to first of all bid farewell to our AD, Alyssa, who will now be stepping up as IETF chair. So congrats, Alyssa, on that. Thank you very much for everything you've done for Netvc. Alyssa was instrumental in getting us through the BOF and getting everything started here and keeping us on track. So she will be missed. And as some, I don't know if people were in dispatch, I actually missed it, but Alyssa was presented with a turntable that plays Opus, so a little bit of something old and something new. So we followed with that theme, and we have something old and something new.
Thanks. Really, I don't know, eat the mic for the last time. Thanks, and you are obviously in extremely capable hands as your former co-chair is now your responsible AD. So I will be watching from over in the general area.
And so that's the other bit of important news, that replacing Alyssa will be Adam, our former co-chair. So should be perfect continuity in that, and somebody to pester the write-ups. And we want to welcome Natasha, who's stepped up to co-chair in place of Adam, and I'm going to stay on. So today we have on the agenda, there's some more administrative items, look at our milestones and disposition of some of the work group documents that we have. And then we're going to cover the requirements draft updates, and then the testing, and Thor update and DALA update. I'll get to it. No, we don't yet. So if we want to go ahead and get some more volunteers for that, let me switch to that.
Is there anybody that could take notes and do JavaScribe? JavaScribe's an easy job. You just look at the Jabber and stand up at the mic if there's a question to be asked. Thank you. So sorry, I don't know your name, sir. Jonathan. Jonathan's our JavaScribe. Thank you very much. Anyone for a note taking? Oh, you get a star. You get a star, I think. It's like really precious. You can trade it in for nothing, but you can show how great you are.
Just a few high-level items in the major details. Steve, would you be willing to maybe take a few notes? Thank you very much. Sorry to impose on you again, I think. All right, and blue sheets are going around. Make sure you get signed them. The note well is particularly important for this work group. If you're not familiar with IETF IPR policy, please make sure you are aware of it. This work, to remind you, is part and parcel of having an IPR-free standard at the output of this work. So make sure you review that. Any comments on the agenda before we get started?
Yeah, that's me. It's good that we both didn't know each other's names. That makes me feel better.
Love having new chairs. All right, so going on to the first item, reviewing our work group documents and milestones. So we have first milestone of July last year, which we've obviously exceeded, and that was the requirements and testing evaluation criteria documents, if we choose to publish them as informational. And we did decide to choose to publish them, so that's not the question here. But obviously, we missed that, so we'll update the milestone to May. Kind of aggressive, but we think there's not much left to do. We already did a work group last call on requirements last time, but there have been some changes that Jose is going to review that are probably a little bit more than editorial. So we will restart work group last call for 2 weeks after this meeting. And I believe we're ready to start the work group last call on testing, but we'll wait until after the testing presentation to make that call. But the goal is to get both of those done by the May milestone now. So the other remaining milestones, the codex specs and the reference implementations of them were due in May. I don't think there's any reasonable way that can be accomplished. So we're going to update those milestones to December. And there's also a storage format spec, which there has not been any activity on. So that's also being updated to December, but I'd note that without even any individual drafts on that, there's probably unlikely that December date will hold. And then finally, there's a test result document, which again has not been started, but should be relatively straightforward after the testing evaluation criteria stabilizes. This should just be a simple output of that document. All right. So that's it for administrative part. Let's go to Jose is going to present remotely.
Randall's spoken that he might have some problems with the slides and the Zoom video and not on the slide. I guess we just changed the.
Oh, yeah. So we have a different projector in this room because we requested a high resolution projector, and I don't think it gets meet echoed. So
I think the These slides are, the slides should be on the agenda, so you should be able to follow them. The slides are on the agenda, so you should be able to follow with that. Be that way. That's the point.
We can double project if you can. Oh, but you can still project maybe into the meet echo.
Sorry about that.
Any chance somebody has a basic MacBook to VGA dongle?
It would be USB-C.
No, new MacBook, small MacBook.
You just state which slide you're on.
Yeah. Okay, so yeah, apologies to those remote. We'll have to state the slide numbers, and people online will have to pull down the slides and flip them manually. Sorry about that. But those in the room are going to get a very high resolution version of the slides. Okay, so Jose, is he in? I see him coming.
Hello, can you hear me?
Yes.
Thank you very much. So good afternoon, everybody. This is a quick presentation on the Netvc requirements. This is the version number 5 of the document. Next page, please. So it's going to be pretty quick. There are changes to the applications, some editorial changes, some changes to the requirements, and nothing to the evaluation methodology. Next page, please.
On slide 3.
So in the applications, we did some changes to the introduction, some editorial changes. The important change here is to the video monitoring and surveillance application, where we changed the rates that we had originally. So for the 1080p, we had originally only 25 frames per second, and now we added both 25 and 30. For 5 megapixels, we added low frame rate as well, since for surveillance, in many cases, the quality of the pictures is what is important and not necessarily the frame rate. So we added a 12 frame rate and 25 and 30 for adding higher temporal resolutions. And for the 4K case as well, we went from the low frame rate to adding 25 and 30. So this is just to cover a wider range of surveillance applications. And that's that for the application section. Next page, please.
Slide 4.
So there were some changes to the general requirements, and that was mostly for section 3.1.1 and 3.1.3. For 3.1.1, what we wanted to do is to mention compression performance, and so that the compression performance would be good for both what we call easy material and difficult material for natural content. So that is, we would like to see improvements not just in the easy scenes, but also in scenes that have a lot of detail, a lot of motion. And so that was the thinking in changing the wording for that section. Also to add explicitly a call for screen content sharing for both moving, which is static, and also dynamic screen content sharing. So that's that was the changes to that requirement. For 3.1.3, we had mentioned syntax that would allow extensibility, but we wanted to make clear that this is explicitly the bitstream syntax, and that we recommend that there is backward compatibility. And so in this case, backward compatibility means that the changes to will not affect legacy decoders. And by legacy, we mean just simply decoders that are working at a specific profiling level will not be affected by future changes to the encoder. So that's really the essence of the changes for 3.1.3. So backward compatibility for a specific profile and level. Next, please.
So just before we go on, so this is where I thought the changes would be really more than editorial, and I think this is where we need to reset the work group last call. So I'd ask the work group to please review this. I think this is more of a substantive change, and we should realize what this means, that explicitly calling out screen sharing performance being part of the target is significant, and requiring backward compatibility for first generation encoders versus later decoders is quite a requirement too. So I ask the work group to please review those during the next last call and make sure you weigh in on your views on them. Now I'd note that in other standards, for example in HEVC, the first version did not have any target for screen sharing performance, and it's not until version 4, which was just published a few months ago, where screen coding performance actually ended up being significantly better. And if we're setting our bar relative to industry standards now, this is even a more important thing to keep in mind. 25% better than the latest December state of the art is a pretty significant undertaking. We're on slide 5 now.
Any other comments?
No, go ahead, Jose.
Okay, so next slide, please.
Yep, slide 5.
Okay, so for the basic requirements, so we just went to the general requirements. Now for basic requirements, there was a change to support of efficient random access point encoding. We had that before, such as intra-coding or resending of context variables, as well as efficient switching between multiple quality representations. So this is something that we talked about before, that would be a requirement in order to allow efficient random access encoding. For 3.2.3, that has to do with complexity. And here, what we wanted to add is a specific sentence that would point towards reasonable complexity of hardware and software encoder implementations compared to what we have today. This is always, we had in the document, well, we still have in the document requirements that for the high quality encoding, the encoder should not be 10 times as complex as what we have today. But this particular paragraph compares with the current state of the art, which is VP9 or 265. And so that's the added text for this. And by meaningful improvement, we mean to say that there's improvements that are visible, whether we in whatever way that we decide to evaluate them, whether subjectively or objectively. And then there were no changes to the text for the optional requirements. Any comments on this? Okay, and that's basically it.
One thing, Jose.
Tim Terryberry from Mozilla. So just a question about that better? All right, Tim Terryberry from Mozilla. Just a question about the first bullet point here. This doesn't say much about when you have to be able to do this switching. Is your estimation
Right.
that something like, periodic aligned keyframes across multiple quality resolutions would be good enough, or do you envision this as requiring something like S-frames?
Tim, I missed the last statement that you made.
Do you envision this as requiring something like S-frames, or would periodic aligned keyframes be sufficient to meet this requirement?
Yeah, I think that would be sufficient to meet that requirement. Correct.
Okay, then I think that's fine.
Thank you.
Okay,
And then
On
the
slide
next
6.
page is just the ending page.
But just for Jose's benefit, there's a quick exchange there. Tim will be sending some proposed text to the list on that.
Thank you.
Just one more question.
low from the floor mic, very low power floor mic. There was, I think, reviewing the diffs for this change. I think there was also an added definition of profiles and levels, and I think that's probably important to call out and have people review what we. It's not defining what profiles and what levels the spec should have, but defining what is constituting a profile and what is constituting a level. So I think it'll be something important for people to review and comment on.
Okay, thank you. Right, so thank you. So those are the changes from the previous version.
All right, and like we said, we're going to start a work group last call, starting now for 2 weeks until until we get all the comments back. And please, we need some more reviewers on this document. I don't think we have enough eyeballs and feedback on it yet to really progress it. So, we get any show of hands of anyone that's willing to review. All right, for the notes, Tim. Anyone else? It's a pretty short document, and the updates are even shorter. Steve, all right, thank you.
Thank you.
All right. Thanks, Jose. All right, so next up is Thomas to talk about testing, and he's also going to do it remotely. So Thomas, if you could come up to the mic queue, mute echo. Is he on?
Okay.
We can see and hear you.
Okay, cool. And I can't, are my slides up? I can't see it all. There we go. Now I can see. So I'm going to present the next update of IETF Netvc testing, and I think it's actually, I think 05. I forgot to update the number on the first slide. But there's only one change this time. So the next step, okay. There are basically 2 new test sets in the testing draft. I didn't remove the old test sets.
Are you able to see me switching? Hey, Thomas, are you able to see me switching?
Yep, I'm able to see the slide. I can read it on the camera. So.
Okay, oh, on the camera. All right.
So there are 2 new test sets. They're objective 2 slow and objective 2 fast. So previously we had the version 1, and so these are basically just these obsolete to old test sets. I renamed, instead of calling it objective 1.1, I renamed it to slow and fast just for less confusion, which reflects what they are. They're basically set up just the same way as their previous test sets, where slow has the very high resolution 4K videos and twice as many videos total as fast does. The next slide. So the biggest difference between these test sets and the previous ones is that these new ones have HDR material. In the test sets, the HDR material is at all resolutions, all the way up from 360 to 4K. It's encoded in HDR10 compatible format, which is basically ST2084 with 1000 nit peak brightness. And they're stored at 10-bit sample depth. That means that all these test sets, even the fast one, now have 10-bit samples in them, which means that you can only use these test sets if your codec supports 10-bit. That's probably the biggest change here. So luckily, the ones we're testing do. So next slide. So the other difference is that we've added 240p content to both test sets. We basically didn't have, we were concerned that we didn't have enough coverage of really low resolution, for example, very low bitrate cell phone streaming for like YouTube and similar use cases. So we added 6 240p clips. We also, because of these small resolutions being much faster to encode than the big resolutions, we decided to extend them to 100. Previously, they were limited to 60 frames, so now 120 frames in length, which is also the iframe interval. The limitation on the clip length is mostly a CPU optimization, so we don't spend a whole lot of time, because the longest video basically limits how long the test takes. So for the small videos, we're not limited by the time they take, so we increase the length to under 20 frames. Next slide. There's other small improvements. Shields 2 had a gray frame in it, so that bug has been fixed. The new version of it is a new test set. The other thing is a couple of the videos have been switched around so that Objective 2 Slow is a complete superset of Objective 2 Fast, meaning that it only adds videos to Objective 2 Fast. Previously with Objective 1, there were some differences between the videos. Like Objective 1 Fast had some videos in 420 format, and Objective 1.1, the slow one, had videos in 444 format. So now the formats have been matched, and you can basically, if you can run Objective 2 Fast and then potentially run the slow version just by running the missing videos, which is a convenient feature. It's not implemented in our compressed yet or any implementations yet, but it's something we could do in the future. I list the end of my presentation. So it's just purely the new test sets. And the old test sets also remain defined in the testing document for people who are already using them. But these ones are intended to replace them. Okay, any questions?
This is possibly a silly question, but I noticed that all your things seem to either be 4:3 or 16:9 aspect ratio. Is there any need to test things that are weird aspect ratios?
So actually, all of them are 16:9. The clips that weren't originally 16:9 have been cropped to create a 16:9 resolution. Basically, the weird aspect ratios, what they have is different border effects. For example, right, because your video codec is limited to say 64:64 blocks. With different aspect ratios, you'll end up with blocks outside of the picture or partially, and you'll have to do weird edge of, special stuff in the encoder. That's actually mostly covered by all the different resolutions, especially some of the 240 clips are at a resolution where they are partial block sizes. So that effect is already accounted for just by having different resolutions. I don't believe there are any other major aspect ratio dependent effects unless you get into extreme long or wide aspect ratios.
All right.
Steve Botsko. This may be jumping ahead a little, but as we look forward to a working group last call, I'm wondering if it makes sense on this document to hold off publication until we're getting close to finalizing the codec specification itself, since we might end up deciding we need to do more extensive tests than we now envision.
Yeah, I do think that's a concern. This document has been iteratively updated. But the other concern is that, yeah, the test document does have a spot for very expensive like MOS score testing. However, that's not really been used, so it's quite likely that there may need to be adjustments made in that part of the document when we actually run one. So that would be a concern for, you know, finalizing it right now.
I don't see any harm in leaving it in draft status for a while longer. So,
So I'd like to hear if there's any other opinions on if we progress the test document or if we just let it remain work group document for longer until the codex are further along. Anybody have any other opinions on that?
Tim Perry from Mozilla. I have basically the same opinion. I think it's fine to leave it open. Don't see any real harm to it.
We also someone in the virtual queue.
Hi, Randall Jessup, Mozilla. I think it's fine to keep it open, as I agree with Tim. Also, just one thing on the previous discussion of the sizes. I'm just wondering whether it makes any sense to have at least a case where it's smaller, where the total width or total height is smaller than one large, 64 by 64 macro block. The 240 case probably does not cover that. And that's a question to the codec people. I don't know what the answer is.
Tim Perry from Mozilla. So I think that's a reasonable thing to use in regression testing. I'm not sure it's that useful in quality performance testing.
That's a reasonable. I agree. That's right. Just I thought I'd mention it. Thanks.
Okay, so it seems like we've had some support for leaving the testing draft open and not trying to progress it now. Is there anyone that feels we should progress it now?
I'm also fine with leaving it as draft for right now until we finalize the subjective testing bits.
John, the only counter argument I would do would be that if you get it done, that means it's not taking up. You can get this document, this working group class call isn't distracting attention from other working group class calls, and maybe you have more cycles to get finished soon. But I mean, if you think that the process of finishing the codex is going to discover, well, then the other counter argument would be having a moving target for what the codecs are being tested as you evaluate them might be harder for the codec developers. But I mean, so I mean, I think there is some benefit to getting it done, and so that that's one more document that's not hanging fire, and two, it's a fixed point for the codec developers to target.
Steve, again, there is a middle ground potentially, right, which is to go through a working group last call, but then not submit it for publication right away. Then you could reopen issues as they come along later, but you'd still know that you have some consensus on the tests that you have already there.
If we intend to continually update it, if that's your intent, that you think there's going to be some substantive changes coming in over the next several months, then I don't see why we would try to push it for publication. If on the other hand you're pretty sure that it's 99% done and that anything would just be minor updates, editorial level updates, or just adding a few more test sets, adding a few more test clips, that would be immaterial to to whether or not we publish it now or later. Then I would say we go ahead and do it now. So I guess really as editor, what do you think is the likelihood of updates here, substantive updates?
So I think I have done, I have so far for each of the last meetings, I think there's been a fairly large update, but mostly it's been a lot of wording changes, but I would actually consider the addition of test clips a very large update because like that directly changes the results you get from the testing draft. I mean, I think that the largest, most likely thing to happen would be for a new set of test clips to be added for some special case. And then also the subjective test section potentially changing. So I mean, if you don't consider adding testing clips to the large change, then we could publish it. But if you don't want to go into a working group last call with the potential for that, then it would probably make sense to hold off.
Okay, I don't think we want to publish stuff just to publish stuff. So it sounds like there's really no strong opinion on progressing it now. No strong opinion favoring progressing it now. I heard a pretty weak opinion from Jonathan, that self-questioning whether or not he really believed that. So I think we'll keep this document open, and I don't think we'll probably need to do a last call on it, because if we intend to progress it later anyway, it would just be wasted work. So probably we'll progress the requirements first, and we'll create a new milestone if we have to for the testing draft. They're both lumped under the same milestone right now. So, feel free to make your updates, Thomas.
Okay.
Anything else on testing?
All right. Thank you.
Thanks, Thomas. Okay, so the next item, we'll have Steiner give us an update on the Thor codec.
I have two topics for today. I'll go through the changes in Thor since the last meeting, which admittedly it's not a long list. Yeah, is that better?
Yeah.
And I will go through an update on the performance. I have new data using RV compressed jets. Previously, we have been using an internal Cisco test set, so I think it's about time to make a switch to what we have agreed on to use in this group. So moving on to the first slide. The new things in Thor, I've added support for monochrome video, which was a trivial thing to add, and also added support for 422 chroma sampling, which I made trivial to add. It's actually encoded as 444 internally, which means that it's very simple to implement and the code remains clean and simple. We don't have to be concerned about funny aspect ratios or rectangular blocks. The downside is that it likely gives us an optimal compression. I don't know how much because I didn't do it the proper way. But I think perhaps 422 is a corner case. One use case is interlaced video, which is an analog 80 years old compression technique, and we might move on to something better now. Perhaps I think some sensors will give you 422, but again, unless somebody can come up with a real use case for this, I would be reluctant to add a lot of complexity in the encoder and decoder for a corner case. So my suggestion is to just keep it as I did for now. And I also made some changes to the CLPF, the constrained low pass filter, some improvements there, which gave 0.4% PDR gain in the high complexity setting. There's a question?
Yeah, actually, question possibly also for Thomas. Is there any 422 content in the testing draft?
Yeah, I think it is, at least in the latest test set. Thomas will know.
Let's take Randall's question first, then we'll get Thomas to answer.
Sure. Mine's on the same issue. I'll note that currently WebRTC code, both in Chrome and Firefox, is very heavily 422 oriented. In fact, it's all 422. So just Just a note.
I think you meant 420 or 422?
422, I believe.
No, I think that's probably a bug.
420? 420 maybe.
Bug in reporting stats.
Yeah.
420 is probably what they're
Yeah,
meant to
it's
report.
probably 420. In any case, it's not 444. And so the question is, how suboptimal is the compression?
As I said, I don't know, because then I would have to implement it the proper way.
Yeah, Tim Terry from Mozilla, not to jump in front of Thomas or anything, but yeah, Tim Terry from Mozilla. One way to actually test that would be to take another codec which does implement it the quote-unquote proper way and see how much difference it makes there. And it's probably at least in the same ballpark in Thor.
Yeah. I haven't done that, but it would give an indication. I agree.
And a test set
Go ahead, Thomas.
only is 444 and 420. There is no 422 in the test set.
Okay, so is that something that you think you should add?
If we're going to support 422, yes. But the main use cases for 422 are generally legacy broadcast applications, which are not nearly as rate sensitive in general. So it's something we could add, but I would
Does
actually
anyone remember? Go ahead.
Yeah, I would actually be pretty comfortable with that being, having maybe that part of just regression testing, or maybe one or two clips that are 422 just to make sure it's not totally broken if we want to support it. But
Does anyone remember what the requirement says about 422?
Yes.
I think Jose is in queue to mention that. Go ahead, Jose.
Yes. Yeah, can you hear me?
Yeah.
Okay, yes, exactly. So I was going to say that in the requirements, we do have a mention of a 422 requirement, but no, I agree completely with Thomas that the reason that it's there is for legacy broadcast applications. So I think that it's something that we need to support, but doesn't have to be optimally supported. I think that most of the material will be 420 and 444. And 422, as Thomas said, we should have, one or two streams just to make sure that nothing is broken. But I think we're okay with having it suboptimally supported.
Okay, then I'll move on. And there are various fixes in 4. For instance, there was a bug in the Chromaton Luma code in the hybrid case. We have fixes for increased portability. And also, we have code that has been taken from Thor and put into the AV1 codec. And whenever that code has been updated in AV1, then I'll try to take that back into Thor. So I would like to keep common code in sync. So I'll give some details on the change in CLTF. CLTF has been presented here before, so I'm not going to repeat that, but just reminding that CLTF is a loop filter. It will modify the pixels by a delta, which is calculated using the surrounding pixels. It used to be 6 pixels. That has been increased to 8 pixels. And also the filter has a clip function, which is restricting the amount of change that the pixel can change. And that has been modified as well. It used to be a pure clip function, taking the difference and strength of the filter. And if the difference was larger than the strength, it would return the strength. An improvement of that is to change the function so that if the difference is very large, then We don't want to modify that much, and we want to leave the image unchanged. So that's what's been done. Next slide, please. On this slide, I've tried to illustrate the new function. It can have 3 different strengths, and that's what the plot shows. The strengths can be either 1, 2, or 4. It's possibly a little bit hard to see on the image here, but we have the high resolution screen, so perhaps we can see it. So what has been added is a ramp down bit. So in this case, in this example, if the difference is more than 32, we will not change the pixel, and if the values are between the strength and 32, it will ramp down gradually. And the function takes another argument, which is the 0 point that we have. So that 0 point will change depending on the quality. So if the quality is high, we want a steeper ramp down, and also if we are encoding chroma, the ramp down is steeper. So this adds some new complexity, but it's still quite simple to implement. It's still SIMD friendly. Everything can be computed using 8-bit lanes, meaning that if you have AVX2 instruction set, you can filter on 32 pixels in parallel. Next slide. So moving on to the next topic, I have ran some experiments using the Arbe compressed get tool. I wanted to include X265 as well, but for some reason I couldn't get that to work. I couldn't get it to work. It had some failure in the build, so I only have 4 compared to AV1. And I think it's useful to have an update on this, since we have switched. I have switched the test sequences. The old set used to be pretty video conferencing centric, so there's now a much wider set of sequences. Another difference is that I used to have clips with 10 seconds of video. Now it's 1 second. It means that it shows much more the in-track performance. I'm not sure if that's very useful, but I guess for pragmatic reasons, the clips have to be short. It's using the Objective 1 set, which, as Thomas said, is now updated. I tried to use the new one, but it turned out that 4 doesn't support resolutions that are not multiple of 16, and I hadn't time to fix that. So I had to use the old test set. And there has been quite a lot of activity in AV1 recently, so it would be interesting to see how Thor compares now. And what I found was that AV1 now generally, at least on average, performs better than Thor. It used to be somewhat worse at compression, but then again, it was something that was very, very close to DP9. So AV1 has progressed. There have been many improvements in AV1 and new tools. I think Thor still seems to be slightly better at video conferencing in low delay configurations. So sequences with meeting rooms and talking heads, Thor performs pretty well. And it's one reason for that might be Thor has 128 by 128 blocks, which helps in quite a lot with these sequences. On the other hand, AV1 is much better than Thor at screen content. And the main reason for that is a new tool in AV1, the palette tool, which helps a lot for some sequences. And when I did this testing, I discovered that AV1 seems to have a 3 to 4 times speed advantage over Thor in the Arbe compressed text service compared to what we have. I couldn't figure out why that was the reason, whether that was because of compiled options or different architectures and so on. So we should probably focus on the compression and not so much on the speed in the comparison that I did. And we'll also see that error resilience, which is the only thing that supports, it has a significant cost. The default mode in AV1 is not to be error resilient, meaning that if you lose some data, then you can't really decode anything until you get an intra update. And finally, AV1 is a moving target, and as we speak, new tools are being added, and in the few next months, we will probably see a 10% improvement, perhaps even more. The next slide. So this shows Thor compared to AV1, and as before, I have the BD rate on the x-axis and the frame rate on the y-axis, but we should probably focus on the x-axis. And Thor is to the right here, and AV1 is to the left, and it's to the left. It's the better side. So we see with error resilience on, AV1 is on average about 4 to 5% better in compression. As I said, I wanted to have X265 here. I would expect X265 to be somewhat to the right of both these lines, but unless X265 have improved a lot over the past year or so. And if we move on to the next slide, we will see what happens if we one backlist, you jump to.
No, sorry.
What happens if we discard the error resilience requirements? In that case, AV1 is almost 10% better. And if we move on to the high delay configuration, then also AV1 is almost 10% better. And finally, if we switch off the error resilience, in the next slide, then AV1 is something like 11 or 12% better on average. But I have to add that there's a lot of difference between the sequences. So on this slide, we see, for instance, the Wikipedia sequence. AV1 is able to slash the bitrate by 80% compared to Thor. And I think that's mainly because of the palette 2. But on the other hand, sequences like curl and also the video sequences, which are video conferencing like, Thor is performing fairly good. This is, by the way, low complexity and high delay. And for some reason, Thor has pretty low scores on chroma and also on SSIM, which is not the case in low delay. If the PSNR difference is 10% there, SSIM is also about 10%. So I need to figure out why this is happening. Okay, so my final slide.
One quick point, since we're deciding to keep the testing draft open, maybe this is a thing to consider. Other standards have broken out the screen content, or in general, different classes of content that are expected to have wildly different results. So maybe it's worth in the testing spec to consider breaking out screen content if the results really do skew things to make them almost uncomparable. Maybe it's worth considering for future versions of the testing document.
On the reports that we get from other compressed step, there is a category for screen content, at least 1080p screen content. But I'm not sure which sequences that included. Probably includes the Wikipedia sequence. I think that sequence alone makes up a few percent of the total.
Yeah, that's really biasing metrics.
So this is our final slide. What next? We don't have a fixed plan. Tor is still using the variable length encoding, and I think the expectation for any modern codec is that it should have arithmetic coding. So one possible solution to that is to use the Dala entropy coder, and in that case, perhaps it's more correct to talk of a merge of Tor and Dala, since the entropy coder is at the very core of a codec. I don't really know how much gain that would give. I think the VLC in Tor is pretty good, but again, I think to be taken seriously, probably need something better. And another thing that could be done is to merge CLPF and Dala deringing, and that has actually been done in AV1. So much of that work is already done. And again, this would take the work in this group towards a merge of Dala and dering. And since these tools have already been adopted in AV1, so this path would take us close to a subset of AV1, or well, actually, it might be more correct to say that it's AV1 that has moved towards what we've done in Netvc, since so much of the work that we have done here has now been adopted in AV1. Other tools from Tor already in AV1 are the 7-bit interpolation filters, some of the coefficients from those filters, and the rest were based on what we had in Tor, quantization matrices and delta Q. Everything is now adopted in AV1. So that's what I have. If somebody has any opinions on how we should progress with the codec work, please speak up. Does it make sense to have a merge? To me, I think it's probably a good idea to see if things converge in some way or another.
Yeah, Tim Terryberg from Mozilla. So I still have my patches to integrate the Dala entropy coder into Thor that I could dust off. Help you out with that if you want.
I think it's changed quite a bit since then. Both of them.
That was 1 year ago, wasn't it? So I think the rebasing is difficult.
Remind the work group that the output of this is intended to be a single specification for the codec. So we're not going to progress multiple codecs. We're not going to look for multiple candidates. We want a single interoperable codec at the end of this work. So anything that can be done to help merge things, I think, would be a big benefit.
Anything else? So, by the way, John Mark is going to say a bit more about the merge of CLPF and Dala dealing.
All right, next up is Jean-Marc. Give a Dala update and see that filter.
Yeah, so there wasn't very much to do in terms of update on Dala itself. So what I'm going to present here is the constrained directional enhancement filter, CDEF, that Steiner was talking about. Next slide, please. So first, so Steiner explained what CLPF was like. So brief reminder of what the Dala directional deranging filter was. It's a filter that operates on 8x8 blocks. It works first by estimating the direction, the main direction in each 8x8 block. This is done only for Luma. Then it uses a conditional replacement filter. So the filter is kind of similar to the CLPF function, except that there is no ramp down. It goes to 0 abruptly. And that filter is first apply along the direction that was found by the direction estimation, and it is followed by a second filter that filters across the lines that are filtered by the first filter to remove remaining ringing artifacts. So in Dala, we used a global frame level strength that was quality dependent. And then each super block, so each 64 by 64 super block would signal a strength adjustment compared to the global frame level. We were using 4 different values, including one value that would be simply turn off the filter. So that's how things worked in Dala and originally in AD1 when we had the deringing experiment. Next slide. So now we've actually merged the Dala deringing filter with CLPF. The result is this CDEF proposal. So it merges the two into a single filter, basically by replacing the second deringing, the second conditional replacement filter in deringing that gets replaced by CLPF. So the resulting complexity is pretty similar to the original deringing proposal, just slightly higher, not very much. The results, on the other hand, they exceed both dering and CLPF alone, and they also exceed cascading of dering and CLPF done independently. The signaling is still done on 64 by 64 blocks. This time we can actually select the number of different strands we have. We can pick one strand for the entire frame, or we can pick 2, 4, or 8. And these are still signaled at the super block level. Slide. In terms of results, this is what we got with our recompressed yet on Objective 1 Fast. We've tested both real-time and non-real-time configurations. What we can see in the result table below is the best results we got were in the low latency CPU used equals 4. That's for AD1. That's essentially a lower complexity setting. That's where we get the best results. Mostly because low latency is not using B-frames, which do some kind of averaging and noise reduction. And it appears that also lower complexity creates more artifacts, so there's more work to do for an enhancement filter. But even at high latency, very high complexity, we're still around 2% improvement in PSNR. Next slide. In terms of complexity, right now at the highest complexity settings, CDEF is adding less than 1% to the encoder complexity. At lower complexity settings, it is still adding 10 to 30%, depending on the exact settings, but that is not very hard to reduce. On the decoder side, the complexity increase is on the order of 12%, but we're still working on more optimizations to do there. We're expecting to get more into the 6 to 8%. In terms of hardware line buffers, which hardware people care about, it has been reduced now down to 6 lines, which was what the original deringing filter proposal was using. And for service strategy, right now we're using the first one, which is the whole frame optimization, but it's possible to simply select, to pre-select some strengths to look at for a frame and just only search that. This is how it was implemented in Dala, and that worked fairly well, so it should also work with the CDEF proposal. Next slide. And so what we have left to do mostly, first we need a perceptual distortion metric. Right now CDEF has a bit of a tendency to blur details in textured areas. So we need to have better encoder decisions to use lower strengths in these areas. We have yet to apply entropy coding to the strengths, so that should help us reduce the signaling overhead slightly. And last step is we need probably to optimize interaction with other tools, because if we're able to reduce ringing, then we can configure other tools to get better quality and allow more ringing, which will then be removed. So there's still some work to do in integration there. Next slide. And so here we have, I think it should show up on the projector, comparison of with the kind of deringing that can be applied here. This is an example with low latency at low complexity. So a case where we see the most difference. So you can flip maybe back and forth between the slides. CDF disabled and this is enabled. And that's it. Any questions?
So I'll just say it's great to see a merge of some of the ideas. I think that was the whole spirit of the work that we intended to have done here. So good to see that the Thor and Dala teams are working together and getting some of the common tools merged together, and the results are pretty good too. And I don't know if people noticed or not. I'm going to go back to a particular slide here. This is what actually surprised me, that the results are, you know, and I think Stunner even had up to 10% performance improvement when you use faster settings, when you're trying to do real time. I think that's a significant advantage for this filter, that if it can really help to improve the quality of the video visually and objectively when you're in time crunches, it'll allow the codec to take corners in other areas and hopefully achieve real time. It's one of the main differences I see between a lot of the other work and other bodies and the work we're doing here. In the IETF ART area, we care a lot about real time encoding, and you know, some of the other video standards are much more focused on offline streaming, so they only care about decoding speed but never real time encoding. And I think this is a really great tool for improving the cases where you're under real-time encoding constraints. You can really take corners and still make up the difference with this filter. All right. Thank you. So any other questions or comments before we close? Done a little early today. Get 15 minutes back. Is anybody missing signing of blue sheets? Anyone else need blue sheets? All right. Thank you very much. Tasha's got one. Sure. Sure. You want to take them? All right. Thanks for sticking for the whole time.
Thank you so much. I could take a few of these, like when you were talking, and yeah, just for the.
Anytime it's you, because I don't actually know the email, but
Nothing burned down.
Nothing written down. Even when I stepped out, nothing written
Yeah, this is. Yeah, sorry. I'll introduce myself on the list, I guess. That would be the idea, right?
down. Yes, thank you very much.
That's okay. I'm gonna go and speak now, and if there's anything else you think I need to let you know, I'll introduce myself on the list. I'll find it in the email.
Where did they put the stars? Where did they give out so many?
When they occur.
Good. Sure. Milestones, yes. Yes, I need to update. So, we're thinking about just speculatively changing the other ones to December.
Yes, which is why it's kind of like my last year. I would expect input and then work and then milestone as opposed to bang.
Well, I mean, we've been trying to get input sooner, and they're saying closer to 3 weeks.